Now it has negative 0.075. Nothing changes. Anyone, please?
Is it 0.925?
Where do I write 0.925?
At the bottom, and then e to 0.925 at the top.
So let's go back. So when we looked at e, we had e to 7x. To find the function, we wrote e to 7x over 7 plus a constant c. When we had 3, we wrote e to 3x over 3 plus a constant c. So what do we have to write now? Anyone?
E
Yes?
to 0.925
So let's go back.
or 37 over 40.
E to 3x. It's e to 3x divided by 3 plus a constant c.
So 0.925x.
This is 3. Did we do anything to 3?
No.
No. So for e to the x is not the same.
To the negative 0.075x divided by negative 0.05.
Exactly.
Now how come we didn't add a 1 to it?
Because this is not a power rule. This is the rule for exponentials. The rule for exponentials is not the same with the power rule for polynomials. This is not an exponential, this is a polynomial. I increase the power by 1 and I divide by the same number. But when I apply the same procedure for e to the x, I have e to 3x over 3 because this derivative will give us that. If you change the 3x or something, you're not going to get this derivative back. So e to 3x prime is e to 3x times 3, and then you cancel the 3 and you're back here. It's a different formula because it's a different function. Is that okay?
Yes.
So now I do have to divide this by this, and I get a negative number. So I have 2500 divided by 0.075, and I got an ugly number of 3333333. So this is negative 33333.33 e to negative 0.075x plus a constant c. Okay, so let's look at a word problem. How important this is. I mean, why do we need it? So here's an example. And then we'll stop. Supply for marginal supply. Keynes Corporation finds that the rate at which it supplies, not the function, right? The rate at which it supplies plates changes with respect to price and is given by the marginal supply function, which is a derivative. So I'm going to write it, and I'm on page 10. I'm going to write it down. So we have S prime of x equals 0.24x squared plus 4x and plus 10. This is the rate of change of supply. X is the price per plate in dollars. So the measurement unit is dollars, right? Find the rate at which supply changes with respect to price, and it's given by the marginal supply function. So it's units per price. Okay. Find the supply function. This is the rate of change. We want to find the supply function, so they're asking us to find S of x. If it is known that they sell 121 plates when the price is $5 per plate, So $5, 5 comma 121. Supply is 121 when the price is 5. So this is the indefinite integral 0.25 x squared plus 4x plus 10. Please remember this symbol does not exist without dx. So it's the integral from s prime of x dx. And please tell me what to write. The front constant will wait patiently. I need the function whose derivative is x squared. Now this is a polynomial. I have to use the power rule. Yes, plus 4 stays and waits patiently. I need the function whose derivative is x.
X squared over 2.
Excellent. I need the function whose derivative is 10.
X.
Yes, and I need a function whose derivative is 0 because there is also a 0 here. Yes, excellent. So I'll simplify a little bit. So I have 0.08 x cubed. I've divided these two, plus 2x squared plus 10x and plus c. And now I am told that the function is 121 when x is 5. So the function 121 equals, when x is 5, 0.08 times 125 plus 2 times 25 plus 10 times 5 plus c. From here I will determine c. So c is 121 minus this, minus this, minus this. 0.08 times 125 minus 50 and minus 50 again, 50 and 50. So what do I get? 121 minus 0.08 times 125 and minus 100. So I got 11. C equals 11. So therefore the function s of x equals plus 11. 0.08 x cubed plus 2x squared plus 10x plus 11. We were given the rate of change of supply function, not the supply function, but the rate of change. We were given that when the price is 5, the supply is 121. We used the indefinite integral and the procedures of finding the most general antiderivative. The functions whose derivative is this. But now we narrow it down to only one because we were given when x is 5, the function s of x is 121. We created this equation. We plugged in x, which is 5. We replaced s of x by 121. This is all algebra. I moved these three pieces to the other side to find c. 121 minus this, minus this, minus this. After all the calculations were completed, we got c equals 11. I have to go back and plug it in. This point was given to us exactly for this, to find c. So this is the supply function, a unique supply function, not a family of functions with the same derivative. That was this one. But since I have the point, I will determine only one function. And this is the supply function, guaranteed to pass through this point and guaranteed to have this derivative. And there is no other. So we were given the derivative and we were able to determine